Welcome back to AI on AI, where we go deep on models that think, act, and now collaborate inside a single brain. Today, we're unpacking chain of agents and agent foundation models, AFMs, that fold multi-agent workflows into one end-to-end trainable model with multi-agent distillation and agentic RL.
The headline is simple but profound. Instead of wiring together many LLMs with prompts and glue code, AFMs learn to do multi-turn, multi-tool, multi-role collaboration natively. In practice, that means the model can internally activate roles like plan, reflection, verification, and tools like search, crawl, code, then evolve its state ST with each observation and role choice 5 sampled from P-Phi-ST.
And the engine that makes this work at scale is twofold. First, multi-agent distillation, recording expert multi-agent trajectories, converting them into chain of agents traces. Then SFT with observation masking so the model learns policy, not snippets. Second, agentic RL on verifiable tasks using DAPO for stable updates, with reward designs that are lean and robust. Binary LLM as judge for open-ended web answers, and exact execution signals for code and math.
From a strategy lens, this is a shift from orchestrate many models to train orchestration into the model. That unlocks speed and cost. One study here shows 84.6% token reduction versus traditional multi-agent setups, while improving success on Gaia, WebWalker, BrowseComp, HLE, and it changes operating models. Fewer brittle workflows, less ops overhead, more data-centric iteration.
It also reframes build versus buy. With AFM-style open tooling, you can fine-tune to your workflows, compliance checks, proprietary APIs, ERP calls, without designing elaborate agent frameworks per task. Think of it as moving from process RPA to policy learning, where the policy internalizes when to plan, when to reflect, when to double-check.
I'll add a safety and eval note. The team's progressive data filtering matters. Drop trivial trajectories, 5 tool hops, curate correctness with LLM as judge or test cases, upsample error correction traces with credibility signals. That reduces reward hacking and pushes the model to practice self-correction, a cornerstone for accountable autonomy.
Let's ground this. What exactly is chain of agents behavior during inference, under the hood?
The model maintains a persistent reasoning state. On each step, it chooses a role like think, plan, search, crawl, reflect, verify, calls a tool if needed, ingests the observation at UI, and updates T via FT-1521 This is not React's static think action observe loop. It's a flexible multi-role orchestration with role condition transitions.
The distillation trick is elegant. They instrument a strong multi-agent framework like OAgents, capture agent selections, messages, tool calls, and convert them to a unified schema like think, tools, observation, observation, reflection. SFT minimizes -log PyPT history, but masks observations to avoid copying external content.
That observation masking is crucial. Otherwise, the model memorizes web snippets instead of learning the policy when and how to search. Masking forces it to predict actions given internal state and prior steps, not external text.
The RL stage. What's distinct here compared to prior tool RL work? 2 design choices, data sampling and reward. For WebRL, they filter questions by pass rate RQ using a 72B judge, sample 32 attempts without tools, and drop any question with RQ.3. That ensures you train on things that need tools. Then rewards are binary. 1 if the judge deems the final answer correct, 0 otherwise. No shaping for format because SFT already stabilizes structure.
For code and math, they do R equals score answer tar score format, pass unit tests or numeric match with math verify, and enforce strict call formatting for the code tool, triple backticks, etc., because execution pipelines are brittle to formatting. This choice later explains why the code agent generalizes better to unseen tool schemas that require exact syntax.
Pragmatically, the RL stack uses DAPO, decoupled advantage policy optimization, with 64 prompts, 8 rollouts per prompt, up to 24 steps, and generous context windows, 32K, which is the right balance between exploration and training stability in long horizon tool sequences.
For business leaders, the translation is, they first teach the model the playbook from expert agents, then let it scrimmage on verifiable tasks with hard refs, pass-fail. This cuts ambiguity and lets you measure return on reasoning.
Results. What stands out?
On Gaia with a 32B backbone, AFM hits 55.3% pass at 1, beating many specialized web agents. On HLE text-only, it gets 18%, ahead of strong reasoning baselines. On MHQA, it wins average accuracy across 7 datasets, even when trained only on NQ and Hotpot QA. For math, it notches 59.8% on AM 2025 and strong deltas on Olympiad Bench. Code-wise, Live Code Bench V5 pass at 1 hits 47.9% at 32B. These are meaningful gains for a single architecture spanning web, code, and math.
And test time scaling matters. Best of 3 and pass at 3 give big bumps. On Gaia, pass at 3 jumps to 69.9%. It's the classic sample more, select smarter heuristic. But in AFMs, it pairs especially well because role orchestration yields diverse trajectories rather than minor paraphrases.
Efficiency is the sleeper metric. Compared to mass, AFM uses fewer tool calls and fewer tokens per successful task. That's not just cost. It reduces latency and exposure to flaky tools. My mental model is less chatter, more chess.
Let's step into deployment. What's an enterprise playbook to adopt this?
3 steps. Start with a narrow, painful workflow where you already have instrumented outcomes, say complex vendor onboarding or regulatory research. Use your existing agent pipeline to generate clean CoA trajectories. Fine-tune an AFM with observation masking, then RL on a verifiable subset. Measure with task pass rates and cycle times. Don't boil the ocean. 1 vertical, 1 quarter.
Tool schemas are the contract. Define JSON schemas for search, crawl, code execution, internal verifiers. Lock formatting and keep tools deterministic. Mirror the paper's code agent strictness. Require fenced code and force return types so that your AFM can generalize new tools as long as the schema is unambiguous.
And maintain a reflection-first culture, upsample trajectories where the model made an error, then recovered via self-reflection. Those are gold for robustness.
Let's go deeper. Multi-agent distillation versus classic sequence KD. Why is this different? Sequence-level KD in language modeling transfers token distributions for a reference text. Multi-agent distillation transfers decisions across role activations and tools, i.e., the policy over a compositional action space. It encodes not just what to say, but who should act next and with which tool, which is the essence of agency.
It's closer to imitation learning on hierarchical POMDPs than to text KD, and the progressive filtering, minimum 520 hops, forces the student to internalize long horizon credit assignment even before RL.
Contrarian view. Are we losing modularity by collapsing agents into one model?
Yes, that's my caution. Modular mask gives isolation. If your finance agent goes off the rails, you don't retrain the world. In AFMs, everything's inside one policy. The remedy is to instrument internal roles as glassbox events. Log each role activation and tool call as structured traces, and enforce governance, per role rate limits, tool safe lists, and external verifiers for high-stakes steps.
I'd add that AFM doesn't preclude modularity. You can still sandbox tools, enforce schemas, and even chain AFMs with different strengths. But the empirical evidence here suggests a single AFM beats orchestration overhead in many tasks.
From a P&L perspective, modular isolation is a risk control. Combine both. Keep deterministic guardrails around money movement, contracts, and PII. Let AFM run planning, search, and draft. Then gate final actions through audited services.
Let's pivot to 3 concrete business cases where this matters.
Case 1. A global marketplace cleans third-party listings. AFM web agent plans search, crawls manufacturer pages, uses code to parse specs, reflects on discrepancies, and outputs a verdict. The company saw a near 50% reduction in manual triage and double-digit improvement in first-pass accuracy across long-tail categories.
Case 2. Procurement in discrete manufacturing. AFM combines vendor search with code-based BOM analysis, comparing specs, computing landed risk scores, and verifying certifications. We've seen cycle time reductions north of 30% over 2 quarters, and fewer expensive expediting events because errors are caught earlier.
Case 3. Pharmacovigilance research. AFM deep researches signals across literature, registries, and news. Verification role enforces consistency with inclusion-exclusion criteria. Outcome is fewer false positives in signal detection and faster safety narratives. Importantly, the reflection logs form an auditable chain for regulators.
Technical rabbit hole, reward design, binary versus shaped. The paper's thesis is keep rewards sparse and verifiable. Binary correctness minimizes reward hacking and reduces unstable shaping. Format rewards are redundant if SFT stabilized syntax. I'd still consider minor penalties for excessive tool calls in production. Think OTC-style cost regularizers, but only when you trust the primary reward signal.
Also, their sampling filter, drop questions solvable from parametric memory, prevents the model from gaming RL by parroting. That's a clever way to force engagement with tools without complex environment design.
Tations.
LLM as judge risk. Your reward inherits the judge's biases. Mitigation, periodically relabel with multiple judges, include adversarial prompts to detect reward hacking, and prioritize verifiable domains, code, math, live search with citations. Also, in regulated domains, use deterministic checkers for key fields.
Credit assignment remains hard. Even with DAPO, long tool chains can dilute gradient signal. The training mitigates with rollouts capped at 24 steps and using error correction trajectories. Future work could use learned value functions conditioned on role and tool to prioritize exploration.
Tool brittleness is real. That's why they enforce strict formatting in code. We should extend that rigor to all tools. Schema-enforced arguments, deterministic outputs, and human-readable failure messages the model can parse.
The unseen tool generalization result is intriguing. Why did the code agent generalize better?
Because its training enforced character-level exactness, triple backticks, fenced blocks, so at inference it adhered to novel tool schemas precisely. The web agent, trained on looser schemas, fumbled strict JSON or code wrappers. The lesson, train with stricter format contracts to get better generalization to new tools.
That implies a product heuristic. Teach your AFM the strictest tool you own first, code or SQL, so it internalizes syntactic discipline, then introduce looser tools. Learn precision once, apply broadly.
Emerging markets. How does this play with low bandwidth and limited infra?
AFMs shine at smaller scales too. A 7B backbone with strict schemas can run on edge servers. Couple this with local caches for search snippets, and you get viable field deployments. Think microfinance KYC in low connectivity regions where the agent plans and verifies offline packets and syncs later.
The second-order effect is resilience. Fewer chatty inter-agent messages mean fewer round trips, which is critical on unreliable networks. And the token efficiency gain translates directly to cost feasibility in markets with tight RPUs.
Also, the RL data filters, pass rate thresholds, and dedup free RL help you train small models without wasting budget on trivial samples. That matters when compute budgets are constrained. Integration patterns. How should teams plug AFMs into existing stacks?
Wrap tools behind stable gRPC or REST with JSON schemas. Deploy a tool router that does strict validation and returns structured observations. Persist the entire CoA trajectory for each session in a lake. Role activations, tool params, tool outputs, reflections. That's your audit trail and your training set.
Fine-tune with observation masking and progressive filtering on your own trajectories. For RL, start with your most verifiable tasks. Ticket dedupe with code-based log analysis, invoice parsing with checksum verification, catalog normalization with deterministic validators.
Establish an agent change board. Any tool schema change or reward function change is versioned, tested against a golden set, and rolled out with canaries. What gets measured, gets managed, applies twice with agents.
Any surprises in the paper's analysis that practitioners should note? The computational efficiency outcome is larger than you'd guess. Once the model learns internal coordination, it trims redundant tool calls. Think of it as compressing the agent discourse into a lean policy. That's why it beats frameworks that over-communicate between agents.
Another subtlety, error correction upsampling. Trajectories where the model initially got a low credibility score but recovered are disproportionately valuable. Those teach the agent to doubt itself productively. Call it institutionalized skepticism.
How about test time scaling? When to use best of n versus pass at k?
Use best of n when evals are judge-based and you can afford a selection pass. Use pass at k when any correct final answer counts and you're tapping into inherent stochasticity. Importantly, diversify seeds and encourage role diversity. Prompt the planning role to explore alternative decompositions.
And set budget-aware policies in production. Critical queries get BO3 or pass at 3. Routine ones get single shot. Dynamic budgets based on predicted difficulty. Use your judge's confidence as a throttle.
Let's do a rapid-fire technical deep dive. 3 mechanisms worth copying tomorrow. 1. Observation masking in SFT to avoid copying from tools. 2. Reward gating via LLM as judge for web and exact executors for code. 3. DAPO configuration for long horizon rollouts with per-step caps and adequate context windows.
I'd add progressive filtering, minimum hop threshold, reflection enrichment, and upweight error correction traces. Also the solvability filter RQ.3, train where tools matter.
Finally, strict tool schemas with parser-level enforcement and logging of internal roles for governance. In safety, logs are your lifeline.
Let's bring in a skeptical business angle. What might go wrong at scale?
2 risks. Organizationally, teams assume one AFM can do all workflows. Don't. Create domain-tuned AFMs. Technically, reward drift. Your judge evolves and shifts the target. Fix with periodic rejudging and frozen eval sets. And always keep a human in the loop on irreversible decisions.
And the boring stuff, tool timeouts, captcha walls, site bans. You need robust backoffs, mirror sources, and a retry strategy. Amateurs talk strategy, professionals talk logistics.
Final round, each of you a heuristic for leaders deploying AFMs.
Train policies, not prompts. Distill expert trajectories, mask observations, then RL on verifiable tasks.
Reward what you can verify. Everything else is a nice to have.
Start narrow, measure cycle time and first-pass success, and scale only with governance scaffolding in place.
Treat tools as APIs with contracts, schemas, determinism, and observability, or your agent will inherit your integration debt.
Make the agent doubt itself productively. Reflection, verification, and transparent traces are features, not overhead.
That's a wrap. Chain of agents and AFMs aren't just another agent framework. They're a learning paradigm that turns orchestration into a policy. For builders and leaders, the message is clear. Codify your workflows as data, verify relentlessly, and let the model learn to collaborate within itself. Thanks for listening, and we'll see you next time with more AI that actually does the work. Before we close, let's stitch the end-to-end picture. What Chain of Agents and AFMs bring is a move from orchestrating agents with prompts to training orchestration into the model. Multi-agent distillation gives the playbook, agentic RL sharpens long horizon decisions, and strict tool schemas plus observation masking keep it policy first, not copy first.
Technically, 3 pillars stand out. 1. Dynamic role activation with a persistent state, sys, so the model picks plan, reflect, verify, search code as needed. 2. Trajectory curation with minimum hop thresholds, reflection enrichment and error correction upsampling, RL with verifiable rewards, LLM as judge for web, executors for code math, stabilized by DAPO for long tool chains.
The non-obvious win is efficiency. AFMs compress multi-agent chatter into a lean internal policy. Fewer tool calls, fewer tokens, lower latency, yet better pass at 1 and big pass at 3 gains via test time scaling. It's not just faster, it's less brittle because the coordination burden moved from glue code to learned policy.
For business leaders, the playbook is pragmatic. Start with one workflow where you can verify outcomes, unit tests, exact matches, deterministic validators. Distill your best agent runs, fine-tune with observation masking, then RL only on problems that truly require tools, RQ 0.3, and wrap the whole thing with governance, schemas, logs, canaries.
Integration-wise, treat every tool like a regulated API. Strict JSON, deterministic outputs, clear error surfaces, because unseen tool generalization worked best where the model was trained on strict formats, the code agent case. Learn precision once, apply broadly is a real pattern here.
Risk lens. Remember the judge is a policy lever. Periodically rejudge held-out sets, watch for reward drift, and keep a human in the loop for irreversible actions. Make reflection a first-class citizen so the agent learns to doubt itself before you have to doubt it.
Highlights and numbers, state-of-the-art on Gaia, 55.3% pass-at-1 at 32B, strong HLE text-only, 18%, leading MHQA averages from just NQ hotpot training, big code lifts on live code bench v5, 47.9%, and math, 59.8% IM25, all while cutting multi-agent token costs by over 80%. That's capability with efficiency.
Key innovations to copy tomorrow: multi-agent distillation into a unified CoA schema, observation masking during SFT, binary verifiable rewards, DAPO for long horizon RL, error correction data upweighting, and best of N pass at K test time scaling with role diverse sampling.
Strategic insight. AFMs convert agent ops into data ops. Once your workflows are trajectories with verifiable endpoints, your competitive moat shifts from prompt spaghetti to a continuously improving policy backbone.
Second and third order effects. Lower infra and bandwidth needs mean viable edge deployments in emerging markets. Governance by trace means easier audits, and the reflection logs become institutional memory you can mine for process improvements beyond AI.
End-to-end summary. AFMs fuse multi-role reasoning, tool orchestration, and verifiable RL into a single trainable model that's faster, cheaper, and with the right guardrails, safer. For tech leaders, it's a blueprint of mechanisms to replicate. For business leaders, it's a path to measurable cycle time cuts and higher first-pass success on the hard stuff. As Drucker would say, what gets measured gets managed. And in AFMs, what gets verified gets learned. Thanks for joining us on AI, and we'll see you next time.